Section 9-4, Part 2, describing sequences of rigid motions. A, B, C, D is a rectangle. A, B, C, D. You are given that this rectangle is congruent to rectangle A prime, B prime, C prime, D prime. Describe a sequence of rigid motions that maps A, B, C, D with A prime, B prime, C prime, and D prime. We're going to talk about two different rigid motions that can be performed to map this rectangle with this rectangle. And the first one I'm going to talk about is two reflections. All right, let's think about, here we have our rectangle in quadrant 1, okay? I can first reflect this rectangle over the y-axis. If I reflect this rectangle over the y-axis, this is what it would look like. I would end up reflecting it right here. Remember, if A is 1 unit from the y-axis on the right side, then A prime would be 1 unit to the left of the y-axis, or your line of reflection, okay? So, this is one reflection. This would be what it would look like if we took the original rectangle and we reflected it over the y-axis. Now, if I take this rectangle here and reflect it over the x-axis, now think about it, B is 2 units above. So when I reflect the rectangle over the over the x-axis, it's 2 below, okay? So you see I have flipped this rectangle. I've reflected it. I first of all looked at the original. I reflected it over the y-axis. Then I took my rectangle and reflected it over the x-axis, okay? So let's look at it on this picture. Same situation, it's just being shown to us. We used two reflections. We first took the ABCD across the y-axis. We reflected it across the y-axis, and here we are at this rectangle, okay? Then we reflected the image across the x-axis. Remember, if B is 2 above the line of reflection of the x-axis when it's flipped over, B prime is 2 below, okay? And we see that A was 4 above. When it was reflected over, it was 4 below, okay? So this is an example of showing a mapping using two reflections. Next, I want us to use a single rotation. Let's use a single rotation to arrive at the same A prime, B prime, C prime, D prime that we did previously. All right, so here I have the rectangle representing A, B, C, D. Remember, B, we're rotating about the origin. B is the closest point to the origin, so that's the point that when it rotates around, B should still be the closest point to the origin, B prime, okay? So, what we're going to do, if we rotate this rectangle 90 degrees, we would end up something like this, B still being the closest point. Now, if we rotate it 90 more degrees coming on around, that would be a total of 180, and that would be our destination of B prime, C prime, D prime, and A prime. So this is a single rotation of 180 degrees. You see, if I connect the B's, they would form a straight line of 180, okay? So this is a single rotation of 180 degrees about the origin that maps rectangle ABCD to rectangle A prime, B prime, C prime, D prime.